Welcome back, class, to part 2 of our lesson, solving quadratic equations by graphing. So let's look at problem number 3. Solve the equation y equals 2x squared plus 4x. When solving the equation by graphing, what we're looking for are our x-intercepts. So keep that in mind. Our x-intercepts will be where the graph crosses the x-axis. Right off the bat, let's go ahead and label our a, b, and c values. A is 2, b is 4, and c is not there, so I'll put plus 0 to represent c. Okay, let's find our vertex. The coordinates of the vertex are x equals negative b over 2a, comma y equals f of x. So for our x coordinate, we're using x equals negative b over 2a. Let's plug everything in. That's negative 4 divided by 2 times 2, which is negative 4 divided by 2 times 2 is 4. Negative 4 divided by 4 is negative 1. The x-coordinate of our vertex is negative 1. Now we need to find the y-coordinate. For the y-coordinate, we need to take our x value and plug it back into our equation. Our equation is y equals 2x squared plus 4x, and if you want to put the plus 0, you can. Once again, we're taking the negative 1 and we're plugging it into x. So now we have 2 times negative 1 squared plus 4 times negative 1 plus 0. Negative 1 squared is 1. And 4 times negative 1 is negative 4 plus 0. 2 times 1 is 2, minus 4 plus 0. So 2 minus 4 is negative 2, and negative 2 plus 0 is negative 2. The y-coordinate of our vertex is negative 2. So x is negative 1, and y is negative 2. Let's plot that. Negative 1, comma, negative 2. Let's draw the axis of symmetry and label everything. The vertex is at negative 1, comma, negative 2. Our axis of symmetry is at x equals negative 1. Now let's use our scale factor, step number 2. And our scale factor is 2, which means that our parabola will be narrow and it will open up. So from the vertex, let's go 1 unit to the right and 2 units up. Let's draw the reflection. The reflection is going to be 1 unit away from the axis of symmetry. Let's look at what we have so far. Notice how we got really lucky, because if you look at the graph, notice how our x-intercepts are on the x-axis, which means that we're practically almost done. So I'm going to highlight my x-intercepts and then continue the problem. So I've labeled the axis of symmetry. Let's find the y-intercept. Remember my equation? Y equals 2x squared plus 4x plus 0. Our y-intercept is c, and c is at 0. Not only is 0, 0 our x-intercept, but it's also, coincidentally, our y-intercept. So now let's draw the graph. The solutions are x equals negative 2 and x equals 0. And we don't have to make a table because our x-intercepts are on our x-axis. Problem number 4. Solve the equation by graphing. Y equals negative 2x squared minus 4x plus 2. Step number 1, find the vertex. Use the same formula. X equals negative b over 2a, comma, y equals f of x. Find the x-coordinate. So x equals negative b over 2a. Let's label our a, b, and c values. A is negative 2, b is negative 4, and c is 2. Let's take what we have and plug it into our formula. So negative negative 4 divided by 2 times negative 2. Negative negative 4 is positive 4, and 2 times negative 2 is negative 4. 4 divided by negative 4 is negative 1. The x-coordinate of our vertex is negative 1. To find our y-coordinate, we want to take our x value and plug it back into our function. The function's y equals negative 2x squared minus 4x plus 2. So take the x value and plug it in. Negative 2 times negative 1 squared minus 4 times negative 1 plus 2, which is equal to negative 2 times negative 1 squared is 1. Negative 4 times negative 1 is positive 4 plus 2. Negative 2 times 1 is negative 2 plus 4 plus 2. Negative 2 plus 4 is 2, and 2 plus 2 is 4. So the y-coordinate of our vertex is 4. Now let's plot the vertex. Our point is on negative 1, comma 4. Label the vertex. Draw the axis of symmetry. Now let's use our scale factor. Our scale factor is negative 2, which tells me that the graph is narrow and it opens down. So from the vertex, I am going to go 1 to the right and 2 units down. I'm also going to go 1 to the left, 2 units down. I need to draw its reflection. Okay, and class, we have another problem because if you look at our 3 points so far, notice how none of them touch the x-axis. And because of that, we are going to have to make a table. So for my table, it's going to be x and y. Y equals negative 2x squared minus 4x plus 2. For my x value, I want to extend my parabola, so the next number on the right side of my point is 1, x equals 1. So I'm using x equals 1. Let's take that x value and plug it into our function. So negative 2 times 1 squared minus 4 times 1 plus 2, which equals negative 2 times 1 squared is 1. Negative 4 times 1 is negative 4 plus 2. Negative 2 times 1 is negative 2 minus 4 plus 2. Negative 2 minus 4 is negative 6, and negative 6 plus 2 is negative 4. So my next point is at 1, comma, negative 4. Let's plot a point. 1, comma, negative 4. And if I have a point that's 2 units away from my axis of symmetry, I'm also going to have another point on the left side of my axis of symmetry. Draw the reflection. So at this step, I'll go ahead and draw my parabola. I'm not going to continue to make a table because if you look at my points, notice how if we draw our parabola, eventually it will cross the x-axis. And now I'm going to determine what my solutions are. So this is going to be an estimate since the parabola crosses the x-axis at a decimal. So our solutions are right around 0.5. So we'll call it 0.5. And this one is about 2.1, negative 2.1. So once again, we're just estimating since the graph doesn't directly cross a whole number. So the solutions are x is approximately negative 2.1 and x is approximately 0.5. This concludes our video. If you like this video, go ahead and give it a thumbs up and don't forget to subscribe.